Fluorophores can absorb and emit photons with a range of energies. We can represent the range of excitation and emission wavelengths of a fluorophore and their relative likelihoods using a fluorophore spectrum. Let's look at a fluorophore spectrum in detail. The x-axis is wavelength and the y-axis is probability. Let's look first at the excitation spectrum, shown here as a dotted line. This particular fluorophore has an excitation peak around 490 nanometers. This means that 490 nanometer light has the highest probability of exciting the fluorophore, because the energy of a photon with a wavelength of 490 nanometers matches up with an energy transition that's quite likely for this molecule. As you move away from this peak in either direction, the probability of exciting the fluorophore decreases. You can still excite the fluorophore with 460 nanometer light, for example. It's just less likely that any given photon will excite the fluorophore, so you'll need more excitation light of this wavelength to get the same amount of fluorescence. Now, let's look at the emission spectrum, shown here as a solid line. This fluorophore is most likely to emit 520 nanometer light, but it still emits light of other wavelengths. For each emission event that occurs, the fluorophore has a high probability of emitting 520 nanometer light and a lower but non-zero probability of emitting wavelengths off of that emission peak. Because the most likely photon to be emitted is green, we'd call this a green fluorophore. But that doesn't mean it only emits green light. In fact, it's also emitting yellow and orange and even red light, just in smaller quantities than the green light. You'll often see a fluorophore described by its excitation and emission maxima. These are the peaks of each spectrum corresponding to the wavelength that most efficiently excites the fluorophore and the wavelength it's most likely to emit. The Stokes shift is the difference between these two wavelengths. While the maxima are useful numbers to know, it's important to be familiar with the full spectrum of the fluorophores you use, since spectra can vary quite a bit in shape. Shown here are a variety of fluorophore spectra. Some spectra have very broad peaks, while others are much more narrow. Some spectra have multiple peaks. For example, these spectra have multiple excitation peaks, and this one has multiple emission peaks. You should look at the spectrum for any fluorophore you use. All of the spectra shown here are from fpbase.org, which is a database containing information and spectra for hundreds of fluorophores. If you can't find the spectrum for your fluorophore at FPBase or elsewhere online, ask the vendor's technical support if it's a commercial fluorophore, or contact the corresponding author on the paper that published the fluorophore.